Okay, so here I am printing out countdown, right? So far good, Andy and Sonia?
So
You guys
far.
good? So I'm calling my method using a 10. This gets passed into here. As long as 10 is greater than 0, I will print out whatever that number is plus a space. So I'm going to end up with numbers going right across left to right because I don't have an ln. But look at this. I'm calling the function from inside the function,
But decreasing number.
but I'm decreasing the number. So next time around, this gets passed in as 9. Right? 9 is still greater. I keep going around and around until I get to,
This is a finish condition. This is
Right.
our condition to stop our recursion.
so this is the part that prevents what Andy was talking about earlier. The test, once we hit 0, we're out. We finished our, and would this be better done with a loop? Yes.
Do you have to put in like break or anything after?
No, because once this condition is, say we go to -1.
Because if we got -1, it just will stop calling itself.
Right,
It will
so-
not call itself. If it's less than 0 and it's done.
It says, nope, we're done. So then it jumps down to here and then it exits and go back to where you call it. And then it goes to the next one. So we're not breaking it and it's not really a loop. We're calling it repeatedly, which is like a loop. But how this is related is, let's take a look at what a stack is. Let's see, we'll just say memory stack, or what, it's not really a memory stack. Anyway, let's call it a memory stack. Stack-based allocation. Okay, let's see if we have a good picture. Yeah, all these are pretty good. Let's just look at, that's a pretty one. Yeah, we don't need that much detail. That'll work. Whoops, I did the wrong one. Where's open image, new tab? Okay. So that's very small. So as we are doing things in all of our programs at this point, we'll just say that's what we're doing. We're doing everything on what's called the stack. And that's called last in, last out. Yeah. No,
First
yeah, okay.
input, first output.
So what you're doing is, are you guys with me? I call the main function in a program, and we've done that. And then the main function runs the entire time the program is running. And then I call the print function and see how it's stacking up. And then if I call another function, it stacks up here. Let's say this is my recursive function. Well, my recursive function calls another calls itself again. It calls itself again. It calls itself again. Uh-oh, what happened here?
Stack overflow.
We ran out of room in the stack because the stack is a limited amount of memory. We'd have to do a lot more. And I tried once to Stack Overflow Java, and you really can't because it prevents you from doing that.
Story, I have to fix myself. Stack is not FIFO, stack is FILO. First input, who first input, the last output.
Right.
FILO.
Which is what we'll do next. We'll go the other way around.
Yeah.
So we're still, because when we exit this, we're creating a new one, and then we create a new one. But this isn't gone yet because we're still inside that function, but we've called the function again, so we're inside that. So they're all active at the same time. And what Mikhail said is what happens next, we need a new color so that we can erase. Oh, we can't really erase it, deletes the whole thing. Okay, so once this is done and we get to our exit condition, we're at -1. Well, once we hit the exit condition, this guy gets popped off the stack. It's called popped. So that was the last one in. It's the first one out. And so then that brings that result back to this one. And then that's erased, brings the result back to this one. And eventually it comes back to this one where we get our final answer. And we return back to main. Because the answer returns, and once we've exited these, they don't exist in memory anymore. But they keep existing on top of each other because when we call it a function from inside a function, it stays in memory until we go all the way back down with the answers and exit and close the functions. Now, when we create objects in Python and Java, we use something called the heap, which is free memory that's other than this. This is limited. This is limited by how much memory do you have in your computer. And it does that automatically. In C++, that's where pointers and stuff come in and references and things. We have to manage this by itself. How is that for mind numbing? What do you guys think? That is definitely computer science. That's what we're here for, is understanding how things actually work. So if we go too far up, that's called a Stack Overflow, which is where the name of the website came from, Stack Overflow. Because poorly written code overflows the stack and kabooey. You've just blown up your program. I tried to Stack Overflow Java once and I couldn't get it to work. So they probably have some safety net in there so you can't do it, but it's been a while since I've tried to do it. All right, and that is our final thing except for the problem. Uh-oh. So let me stop this recording.